Today we're going to work on learning how to factor trinomials. Specifically, we're going to work with trinomials that have a leading coefficient of 1. But the process that we're going to build will stand pretty much throughout all of the different kinds of trinomials that we work with. So as we get started, let's put your name on your paper and make sure that you can always find yours. So just to help our brain warm up and get an idea of where we're going with these types of problems, let's work a problem forwards before we begin working lots of problems backwards. So if we multiply two binomials together, we have a couple of different ways that we can do that, but let's go with the FOIL method, and let's write that out just so we remember. So FOIL stands for F-O-I-L, where F is first, O is outer, I is inner, and L is last. Remember that? So now let's practice multiplying in that order, and to help us we draw our rainbows. So the first term of each binomial, x times x, is x squared. Good. And then the outers, all the way at the front, all the way at the back, let's multiply those together. A positive times a positive is a positive. X times 7, 7x. Great. Let's go for the inner two terms for here in the middle. Again, a positive times a positive is a positive. 5 times x is 5x. And then last, a positive times a positive is a positive. 5 times 7 is 35. Great. So to finish this off, you're going to want to combine like terms. There's only one x squared term, so there that is. And here are two simple x's, so let's combine those together. So 7x plus 5x makes 12x. And finally, a constant of 35. Ta-da! It's done. There is our final multiplied answer. Great. So that's working forwards. I hope that's like, oh yeah, I remember how to do that. Let's talk now about working backwards. And this is called factoring. So as we factor, we are given a trinomial, and I want to know what two binomials it came from. That's our goal, is to find out where did this come from. In our last lesson, we worked on factoring, but it was what did all three terms have in common, either by dividing by a coefficient or they all had a variable in common. And these three terms have nothing in common at the moment at all. So we're going to see where this is a quadratic, where it came from, and these two binomials lead to the roots, or the zeros, the solutions, the x-intercepts. So we worked on this a little bit, just a little bit, in our quadratics unit, I don't know, a few weeks ago. So let's begin this process. So to get started, we list out what is A, B, and C. So remember, if you're like A, B, and C, what? You say, oh yeah, ax squared plus bx plus c. So what is in the A location? 1. B location? 12. C location? 35. Great. And what you're going to do at this point is to draw a square. And you're going to put a giant X from corner to corner, diagonal to diagonal. And each of the quadrants, each of the triangles that we have created has a special job. The first triangle will always be A times C. The bottom triangle will always be B. And we're going to find out what creates the wings. That's how we're going to build our two binomials. So A times C, 1 times 35. So you can write that out just to help you as we get started. For this problem, it's 1 times 35, which is, 35. And whatever B is, that's what goes in the bottom triangle, 12. So our job is to now look at what are all of the possible pairs that could have multiplied to make 35. So we build a small t-table, but we don't put an X and a Y at the top of it. No, we're just looking at whatever is in this top triangle. I want to tear it apart to see what could have multiplied to make that 35. It could have been 1 and 35. It could have been 35 and 1, but that's the same thing. It could have been 5 and 7. And there are no other pairs of numbers that would multiply to make 35. So now that we have all of the pairs of multiples, we're going to look for this 12. We're going to do that by adding straight across for these pairs. So 1 plus 35, 36. 5 plus 7, 12. Hey, winner, winner, chicken dinner, that's what I want. I want this 12 right here. So these two numbers, the 5 and the 7, go in my wings, so to speak. Okay? So it doesn't matter if the 7 is on the left or the 5 is on the left. It really doesn't matter. So you just need them both there. So to get this figured out now, we slide back over to my binomials. And what happens is I always have my X at the front of my binomials. These are both positive. Both of my wings are positive, 5 and 7, so this will be plus and plus. And what happens is I have a wing divided by A, and then I have my other wing divided by A. All right? So that means I've got X plus my first wing, 5 divided by A. What is our value of A? 1. Times X plus my other wing divided by A. So 7 divided by 1. And now let's just finish it off by simplifying and cleaning up my binomials with my fractions. And we have X plus 5 times X plus 7. That is my final pair of binomials. We've got it. So yeah, that was the exact same problem as the first one where we multiplied. But it was kind of nice to see we know how to build the trinomial. Do I know how to tear it apart to get what I started with? And that's what we're trying to do, okay? So some people call this the X method, some people call it a box type method, some people call it the Mustang method, but it's all the same. And there's an acronym for the Mustang method. If you ever wanted that, come and talk to me. So let's go start on problem number 1. Let's get an idea of getting our gears going and practicing how to do what to do. So here on problem number 1, let's see, A, B, and C. We've got some space. We're going to use a lot of space. So A is 1, B is 6, and C is 8. Great. So let's build our box. Use your space really smart, really careful. Good handwriting. Man, oh man, good handwriting. That's a make or break type moment. So A times C always goes in the top triangle. B always goes in the bottom triangle. A times C, so 1 times 8, 8. Bottom triangle is B, so that's just 6. Watch your handwriting. Make sure you know the difference between your 6 and your B. Now let's build our T-table. We want to know where 8 could have come from. So options to multiply and make 8. We could have said 1 times 8 and 8 times 1, but that's the same. There's also 2 times 4. And yeah, 4 times 2, but that's the same thing. Is there anything else? No, there's not. So let's add them together. Let's add our rows straight across. 1 plus 8 makes 9. 2 plus 4 makes 6. Did I need a 9 or a 6? Oh, I need a 6. So this is the pairs, those are the wings that I need for my X. Great. All right, let's go build our binomials. So now I've got X. This is a positive, so plus sign, 2 over A. A is 1. Start up your second binomial. I have an X. This 4 is positive, plus 4 over A. A is again 1. Great, we're almost finished. So now let's just simplify our fractions. X plus 2 divided by 1 is 2. X plus 4 divided by 1 is 4. And we're done. These are the binomials that when you multiply, you will create this trinomial. Now you might say to me, hey, we had a G for giraffe, and now you have an X. What's with that? You're right. I kind of went on autopilot. We usually switch with X's. It's just most of our problems involve an X. Does that mean that the process has changed? No. And if you're like, shoot, I want to make sure that I'm going to get all of my credit. Okay, well, let's go put our G's back in there. And if you're nervous, which happens, you can say, here we go. And I don't even like this one because it has X's in it. Okay, well, there you go, folks. So there you go. You've got your G's, just like our original problem. And autopilot happens, but if you're working in pencil, like you're supposed to, that's a really easy thing to fix. Okay, let's go look at problem number 3. It's mostly the same. It's a little bit different. We've got some negatives in there, and we're going to see how that changes stuff up. So A, B, and C. A is 1. B is -6. C is -7. Great. Let's build our box with the X in it. Do you remember what goes in the top triangle of your box? Good, it's A times C, which in this case is 1 times negative 7. Ooh, yeah, you got to take that negative with you. That might do some different things. And in your bottom triangle, that's always the letter B, which is negative 6. And again, you've got to have that negative. It changes things if you don't. It's a game changer. Now, let's go build our t-table. And I want a negative 7. That's what we are after. So to get a negative, I need to multiply a positive times a negative. And that will change your answer when you are looking for what you need for the bottom triangle. So positive 1, negative 7, or negative 1, positive 7. Okay? So positive 1, negative 7, that makes negative 6 when you add them straight across. If you want to, you can put a little plus sign in there if you want to. And you would type that straight into your calculator. It'll help you. Negative 1 plus 7 gives you a positive 6. What do you need for this problem? You need a negative 6. You need this set. 1 and negative 7. All right. Let's go build our parentheses, our binomials. So we'll remember what letter, what variable we're using. B. This is plus 1 over my value of A, which is 1. And B minus my wing of 7 over my value for A. Okay? So my wing that had the 1 was positive, and my wing that had the 7 was negative. So I just have a plus and a minus. So let's finish this off. B plus 1 times B minus 7. And there it is. Good job. How are you doing? You doing okay? So I want you to go and try number 2 and number 4. So stop the video. It'll take you a little bit of processing, but it'll be okay. Be very careful with your pluses and your minuses. Come and ask me if you need some help. All right, on this next section, we are encouraged to use the box method. I'm just going to tell you don't. I know it's here. Don't do it. Just don't. Use the X method that we've already been doing. I want you to have clarity. I want you to have good, solid understanding of this process. I think it will cause more problems to give you a different method. And this method you will not see on the state tests. You just won't. So let's stick with what we already know. And actually, let's start up with problem number 6. Let's do number 6 together. So if you want, we can revamp this box since it's already here. Why not revamp it? So this will be A times C on the top and B on the bottom. All right, let's go find A, B, and C. Can you get them? A, B, and C. What is A? Good, it's 1. What is B? Whoa, negative 16. And what is C? 60. That's huge. All right, let's go get it. So A times C, 1 times 60, 60. And then B is negative 16. All right, let's go make your t-table. Now, here's a little throw at you to try and see if you can catch yourself. I need a negative value for B. So I know at least one of my factors has to be negative. But 60 is positive. So that means both of them have to be negative. So it'd be negative 1 and negative 60. Negative 2, negative 30. Negative 3, negative 20. Negative 4, negative 15. Negative 5, negative 12, negative 6, negative 10. And I believe those are all of our pairs. So let's go find their sums. Negative 61, negative 32, negative 23, negative 19, negative 17, negative 16. Which one did I need? I needed negative 16, and there it is. Negative 6, negative 10. All right, now we can go get our binomials. Let's build them. X minus 6 over A. What was A? 1. And x minus 10 over A, what was A? 1. So my final answer will be x minus 6 times x minus 10. Done. That wasn't so bad. Nice job.